Quarantine Science Lab.
Good job, Baba. So today on Quarantine Science Lab, we have a really, I think it's an exciting demonstration. We're going to demonstrate something interesting that you may have never seen before, and it's pretty cool. All right, so we have here steel wool and paper. So first, we're going to weigh the paper, and we are going to, and when I put the watch glass on the scale and I turn it on, it automatically tears the scales to account for the watch glass. So now when I put the paper on there, we can see that the paper is 65 milligrams. That's our starting mass. Okay? Now, when I burn the paper,
wow, that's
it's
so
dropping.
sad.
It's dropping. It's down to 34 milligrams, 31, 27 milligrams. It's still burning.
It's so satisfying.
Yeah, it's disappearing. 13 milligrams.
Let's see if we can light it more.
8 milligrams. Don't blow on it. See, I want to avoid setting off the smoke detector. That's why I keep it. 6 milligrams. We're almost done. It's still, there it goes. That's a little bit more. There's a little bit of paper down there that didn't get burned.
It smells like barbecue.
5 milligrams. We're down to 0 milligrams. It literally says 0 milligrams.
Wow.
So the ending mass, 0 milligrams, starting mass, 65. That makes our percent, our delta. Do you know what delta means?
Nope.
Delta is the change. So when I write delta, when a scientist writes delta mass, they mean the change in the mass. What was the change in the mass? It's negative, right?
Yeah.
Negative 65 milligrams, right? And then the percentage change is negative 100%. Negative 100%. All right? Now, first, let's measure the mass of steel wool that we're going to burn. Tear the scale. It's at 0, so let's I've carefully constructed this to maximize how much of it gets burned. Now, we have 383 milligrams of steel wool there. Here.
Okay, so like I'll do your hand.
Okay, you can guide my hand, okay? All right. Whoops. Now, some little particles are flying off the surface, but
That doesn't matter.
the mass appears to be rising. Now be very careful not to breathe over there. And I'm going to be careful to light the lighter far away and then apply it, because I want to make sure the whole thing burns. Okay, interesting smell, isn't it?
It smells good.
Now we're up to 404 milligrams, 408 milligrams. I think there's a little bit of steel wool in there that's not getting burnt yet. 411 milligrams is the ending.
I'm still gonna try and practice.
So the delta was 17 plus 11 is 28. The delta was a positive increase of 28 milligrams. So let's find out the percentage delta. I don't have my calculator with me, so I'm going to do a little bit of math down here on the scratch paper. If we divide 380, if we divide 28 by 383, it was an increase of 7.3%. Okay?
I'm trying to get it to light. I'm pushing it so
I know, it's child. So let's go over this. So when we burned paper, we observed a 100% reduction in the mass of the paper between the beginning of the reaction and the end of the reaction. When we burned steel wool, we observed a 7.3% increase in the mass of the steel wool. I have a feeling that if we did a bigger piece, that we would observe a bigger increase in the mass. But that's just our results here today. Can you explain to me, well, first off, let's talk about why the paper decreased dramatically in mass when it burned. Can you explain that to our viewers?
Because
What's paper made of mostly?
trees. And
Yeah.
trees are kind of flammable.
Carbon, and mostly carbon and water with a bunch of other little trace minerals,
Yeah.
right? But mostly it's carbon and water, right? And carbon reacts with oxygen. And what happens when carbon reacts with oxygen?
Makes fire.
What it produces,
It produces
carbon and oxygen molecules reacting together produce,
water.
no,
Ugh.
it produces carbon dioxide,
Carbon dioxide.
which is a gas, right? So that gas goes away into the atmosphere. What happens to the water that's in that paper?
It dries out.
Well, it evaporates,
Yeah.
it goes to steam, and then that's what the smoke you see is mostly steam, right? Because carbon dioxide is invisible. So when you see smoke coming from a paper fire, what you're seeing is mostly water vapor condensing in the air. So the paper loses both carbon and water as it reacts with the oxygen in the atmosphere. But what about the steel wool, which is iron? What happens when iron reacts with oxygen in the atmosphere? It creates iron oxide, mostly iron 2 oxide, which is Fe2O3. So each 2 molecules of iron grab 3 molecules of oxygen, and they stay attached to the object, which in this case is the steel wool. So it's grabbing oxygen out of the air, converting it to a solid, and it is clinging it doesn't float away. It stays with the ashes of the steel wool. So this steel wool now has more mass than it did before we burned it. Isn't that cool?
Yeah.
All right, bud. Thanks for your help. Next time, maybe you can work the lighter. Proof, bud. And how old are you?
8.
You're a very precocious 8-year-old, but you still can't light a child-proof lighter. To start this reaction requires us to input energy in the form of heat.
Wait, can we?
All right, you did real good. You can go back to watching educational things on YouTube. You were watching Nile Red, weren't you?
No, I was watching Fortnite.
Weren't you watching Nerd Rage? Crash Course? Weren't you watching John and Hank Green?
I was watching Fortnite.
But you love to watch Crash Course, don't you? So why don't you say hi to all your favorite internet people like John Green and Hank Green?
Hi.
Who else do you love? You also love slow-mo guys, Gavin and Dan, right?
Yeah.
Say hi to Gavin and Dan.
Hi.
Hi, Gavin and Dan.
Hi, Gavin and Dan.
And what about Nile Red?
Hi.
I don't know his name, but we watch his videos
Yeah, we
like
definitely
they're
watch.
going out of style. All right, Baba, good work. Hey, thanks for watching Quarantine Science Lab.
Hmm.
Very nice.
Yoshi.